Hello students, welcome to third video of electricity chapter 12, and the topic is potential difference. In previous classes I have explained you what is electric current, and in this section we are going to study what makes electron flow, what makes electricity flow. The reason being potential difference, but before understanding the potential difference, which is the reason behind the flow of charges, it is important to discuss what is potential. There is analogy I have to make you understand what is potential, and very familiar topic I am taking to you to make it very much clear to you. You must have seen the bar magnet, and here I have taken this bar magnet. This is the north pole, and this is the south pole. And when this magnet is kept in space, around it there is a region of influence created. Region of influence means inside the circle, if any other magnet is brought, it will attracted or repel depending upon the polarity. Means if south pole brought to south pole of this magnet, it will repel, and if north pole is brought close to this south pole, it will be attracted. Like poles repel each other, and unlike pole attract each other. You must be familiar of it. And the major motive of mine behind it, that there is a reason around the bar magnet, and in this region, there you can see, here you can see the points, here you can feel the presence of the magnet. And if any other magnet, suppose this magnet you try to bring in this direction, and the polarity is, suppose this is south, and this is north, in that case you have to do some work, because this magnet A and this magnet P will repel each other. To overcome this repulsion, you have to do some work. In the same way, there are condition with the charges also. I have taken here a charge Q, and around it a region created. This is the region of influence. This is the region of influence. Here its presence can be felt, and I'm giving it a name inside the circle, not giving name, inside the circle, and outside of the circle simply I'm saying. Outside of the circle, suppose I have taken a point A, this point A. Here its presence cannot be felt. Here its presence cannot be felt at point A. Suppose another charge I have, Q, positive charge, and I am bringing it towards the region of influence of this charge. Then I have to do work in the same way as in the case of magnet. In this case, we have to overcome the repulsion, because this is also a positive charge, and this is also a positive charge, this is also a positive charge, and we have to overcome the repulsion. We have to do some work. Actually this work is done by the battery inside a conductor. Whatever I am explaining you here, it is happening inside a conductor where charges are moving. And who is responsible for the movement of charge? Definitely battery providing a potential difference. Here I am trying to make you understand what is potential, and then I will try to make you understand what is potential difference. here you understanding in both the cases, in the case of magnet and in this case of charges, two charges, same charges. Here if you bring one charge in the region of another charge, you have to overcome the repulsion force. And in the case of magnet also. So what is important thing is here, we are bound to do work when we bring a unit positive charge from point A, this I am saying, from point A to inside any point in the circle, we have to do some work. This work is called potential at a point inside the circle. More you pushing the charge inside the circle, more work you have to do, and in this way battery will have to do more work. I hope you must have understood it. And whatever I have explained you here, this actually happening inside a conductor. I want to say that this is a conductor, and these are the electrons. Electrons are not I am marking simply a negative charge. This is a conductor, and these are the negative charge, means electrons. These are the electrons. There are positive charge also, but we are discussing only about the electrons. These electrons continuously flowing in the conductor by this battery, okay. Positive to negative terminal current direction, conventional current direction, as I have explained you. And this is the battery which is actually providing the potential difference. Potential I have explained you, it is a simple work when we bring a unit positive charge from infinity to a region inside the region of influence, like this one. Here potential is what? Potential is a work. Is someone asking what is potential? It is a work. I am explaining you again. This is a Q, positive charge, and this is the region of influence. Okay, this is the region of influence, and outside of this circle, this I am called infinity. This is called infinity. Okay, and from infinity I have taken a point, suppose A. If a unit positive charge, another charge, if you bring this side to this region, you have to do some work. That work is called the electric potential at this point. Okay, this is the electric potential. And what is potential difference then? Definitely if you bring positive charge, this is, and 2 point I have taken, point A, point A, point B. Both will be at different potential. Point A, this is point B. If you bring a charge from point A to B or B to A, and point A and B both will be at different potential, and difference between the potential of these two point A and B is called the potential difference. Means, as here it is written, you read it, you read this line, you read potential difference between 2 points is the amount of work done. Means, if battery push the electron from A to B, battery will have to do some work. That work is called the potential difference between the point A and B. Keep in your mind, only unit positive charge is moved from point A to B, and in this way battery will have to do some work, and that work is called the potential difference between 2 point A B. I hope you must have understood what is potential difference. Okay, simply what it is. If someone asking what is potential difference, it is a work. Who is doing the work? Battery is doing the work. In what it is doing the work? In pushing the electron it is doing the work. Where it is pushing the electron? It is pushing the electron in the conductor. As you know, in class 9, work is equal to what? Force into displacement. More the force you apply, more the distance object covered, it means more work done. In the same way here also, for potential difference I have taken a symbol. For potential difference I have taken a symbol V. V. You see this? You try to this way. Potential difference equal to work upon charge. So for potential difference I have taken here symbol V, and for work W and charge capital Q. This formula you keep in your mind, it is important. The potential difference is equal to work upon charge. This keep in your mind. And if I simplify it, a little simplify it, you see, so what I can write it, W is equal to V into Q. The formula is same as you studied in class 9. W is equal to F into D. Sometime in place of D, S is written, no problem. The more the force applied, more the work is done. More the distance covered, more the work is done. In the same way, if the battery voltage is more work will be done by the battery, and more number of charge, a large number of charge suppose is pushed by the battery, again the more work will be done. So you can see there is a great analogy between the two formulas you studied in class 9, and now I am explaining you in class 10. Okay, I hope you must understood it. And as I have explained 1 ampere current in the previous class, in the same way now I am going to explain uh, how much 1 volt is. So simply in this formula, V is equal to W by Q. If I put in place of W 1 joule like this, 1 J, and divided by coulomb 1 C, what I will get? 1 joule per coulomb. So 1 volt is equal to 1 joule per coulomb. as I have explained in the previous video, 1 ampere. So means there are 2 point. When we say that there is a voltage potential difference between 2 point is 1 volt. Again I am taking the conductor. This conductor I have taken, and 2 point I am taking point A, point B. This point A, point B. The definition of 1 volt is electric potential difference between 2 point is said to be 2 point. It is 2, not 2. By mistake it is written 2. It is 2. Okay. Electric potential between 2 point is said to be 1 volt if 1 joule work is done in bringing 1 coulomb positive charge from point A to point B. This I am saying. These 2 point, between these 2 point potential difference will be said to be 1 volt if 1 joule work is done in bringing 1 coulomb charge from point A to B. There is a one note I have taken for you. For a continuous flow of current between 2 point, the potential difference 2 point should be maintained by a battery, and I have explained you if battery is missing, potential difference between 2 point cannot be maintained. This can be understood by one more example if you having any type of confusion. Potential difference I am trying to giving you a visualization of potential difference. Potential difference actually is a condition which decides in which direction current will flow or electron will flow. For example, I have taken here a pole, and this is I have taken another pole. This I have taken a pole, this I have taken a pole, and slope I have taken here, and there is a ball I have taken here. Okay, so definitely capital H is the height of this one. Again I am telling you, don't worry. This is a ball. This is height H. This is height H dash. The H is greater than H dash. You can see H is greater than H dash, and the ball will move in this direction. So what it is saying, what it is showing, it is height is what? Height is the condition with deciding the rolling of the ball from higher place to lower place. In the same way, potential difference is a condition which decides the flow of electron from a higher voltage to lower voltage. And you must have seen yeah, the battery. This is a I have taken positive terminal, and this is negative terminal, and current flow from this direction to this direction, higher potential to lower potential. The potential difference is maintained by a battery. Here I have taken example. Calculate the work done in moving a charge of 2 coulomb through a potential difference of 5 volt. So this question is based on the formula I have explained you. V is equal to W by Q. Here it is given that charge 2 coulomb potential difference 5 volt. So you put the value 5 volt and 5 volt in place of V and 2 coulomb in place of Q, and in this way you get the 10 joule work. So the work how much done? 10 joule. In what it is done? In moving 2 coulomb charge by a battery of 5 volt. And this is another question. Here the question is given, and this also based on V is equal to W by Q and all the values given here, but you must keep in your mind, you step by step try to solve this one, because directly answer is written here. Okay, the indices rule you must have studied in class 9 maths, that you use and step by step you solve it. Okay, and one more diagram here given, so that you can have the better understanding of the visualization of potential difference. And what I have done here, if you see there is a pump, this pump is pushing the water upside, and the water is at this point here is at high pressure, and then it comes to the low pressure here, and the pump is continuously pushing the water upside, and in this way continuous flow of water is maintained by a pump. Pump is actually doing what here? It is creating a pressure difference. It is at high pressure and this point is at low pressure, and there is a difference of pressure difference. The due to pressure difference here, water is flowing. Due to the height difference, ball was rolling, and due to the potential difference, electrons flows. So there is an analogy in these three examples. You see here the battery is actually doing what? Creating a potential difference. Because of that, this point is at high potential, this is low potential. Current is flowing from high potential to low potential, and this is written here also. You can see potential difference is maintained by battery here in this case, and here pressure difference maintained by pump. So pump is very much similar, analogous to the battery. Whatever the work is done by the pump here, the same work is being done by the battery. I hope you must have understood it. And there are two devices now we are going to discuss. Now I am to discuss two devices. As I have explained in the first class of the electric current, ammeter used to measure the current through a conductor. In the same way, voltmeter is a device which is used to measure potential difference between 2 points in electric circuit. Okay, so ammeter for electric current and voltmeter for potential difference. And voltmeter having high resistance, and ammeter has low resistance. What is the resistance? This I will explain you in subsequent classes. Okay, don't worry about that. And voltmeter always connected in parallel. This will also I will explain you in the next class what is parallel. And here third point in ammeter is connected in series. So wait for the next video, there I will explain you what is series, what is parallel combinations, and what is the resistance of a conductor. I hope you must like the class, because every point I have tried to make you clear by the analogy as well as visualization.